Okay, everyone, welcome back. I'm going to talk about the flaws in voting methods. Okay, so fairness criteria are a set of basic rules that define the formal requirements for fairness. We expect any democratic election to satisfy these basic rules. If it violates one of these conditions, there is potential for unfair election results. So rule number 1, the majority criterion. If a candidate has the majority of first-place votes, then that candidate should be declared the winner of the election. Okay, so just to remember, first place majority means more than half. So more than half the first place votes, then that candidate should be declared the winner of the election. Because if you think about it, it's impossible. There we go. It is impossible for an election counted using the plurality method to violate the majority criteria. Okay, why? Okay, because plurality method has the most first place votes wins. Okay, so if you have the most first place votes, you're not going to lose by a majority. Okay, but the problem, our plurality method winner was A in this year, right? Because A had 14. However, where is A on the rest of it? A, like we talked about in the last lesson, I know a couple lessons ago, is A is at the bottom for everybody else besides the 14 people. And if you remember, there's 37 people in this election. They voted, 37 voters. Okay, so where is A? A is at the end, or the last choice. The last choice for, 23 of the 37 voters. It's at the very end. So in other words, the majority does not want A. So the majority of people do not want A in this case. Okay, do not want A. Okay, do not think they can lead. A doesn't seem like a good leader. All right, so that's like the first example. Okay, and that's the table we've been working with throughout this whole unit. Okay, so let's look at example 2 now. It says the band has a choice to perform at 5 different bowl games: the Rose Bowl, the Hula Bowl, the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. Who is the plurality winner? Okay, well, if you look at it here in first place votes, R has 49, H has 48, and F has 3. So the plurality winner would be R, or Rose Bowl. Okay, but is there a better choice? Yes. Why? Because you have 51 people do not want R. The 51 people do not want the Rose Bowl. Only 49 do. Okay. So is there a better choice here? Let's see who it could be. Well, H has 48. And if you look at the second choice, H has the majority of those as well. So H is the better choice. Okay. So this kind of goes into the thing of the way you determine the winner matters. If you do plurality with elimination, H will win. If you do plurality, the Rose Bowl wins. Border count, possibly H. Okay. So let's look at rule number 2 now. The Condorcet or head-to-head criterion. If a choice in an election is preferred over each of the other candidates in a head-to-head comparison, then that choice should be declared the winner of the election. Okay. So if you beat everybody else in a head-to-head, you should be the winner. Okay, and we've talked about the Condorcet copious amount 2 times in class. One of the plurality method's major flaws is that it makes us choose a candidate over a much more reasonable choice. However, just because the plurality method may violate the Condorcet criterion doesn't mean that it will. Example 3. Candidate C won this election using the plurality method. Is candidate C a Condorcet candidate? If not, is there a Condorcet candidate in this election? So the first thing we have to do is put C up against everybody else. So I will just do C against A because it's the first letter there. Okay, so now we're doing pairwise here. So this is a pairwise problem. So these 20 votes here, they go to A. Those 14 go to C. These 8 go to A. These 7 go to C. And then the 2 go to A. So if I total them up, I get 21 to 30. So, no, right off the bat, the first one I did, C is not the Condorcet. So C is not the Condorcet. So we enter the first part. Is there a Condorcet? So let's check another one now. So A won that battle. So let's just keep going with A. A against, we'll go A against D, because D is higher up than B in the standings. Well, let's just do B. Okay, I'm intentionally doing this. B. Okay, so A against B. So A will get the 20. B gets the 14. B also gets the 8. B also gets the 7. And A gets the 2. So we're at 22 to 29. So B beat A. So A is not the Condorcet. So if I'm making a list of possible Condorcets over here, it's not C and it's not A. So it's either B or D. So let's do B versus C just to make sure that B can beat everybody. So B would get the 20. C gets the 14 though. B gets the 8. C gets the 7. And B gets the 2. So I have 30 to 21. Okay, so B won that one. Let's do B versus D. Okay. So B versus D. So B would get the 20. B also gets the 14. So I can see that B is going to win right off the bat. 8, 7, and 2. So we get 34. So what's that? Going to be 17. So B wins. So B is the Condorcet. Okay, so now, what does that mean? Mr. Ball, we've done this method again. I don't understand what this means. Okay, well, if you look at it, B's the Condorcet, right? B's the Condorcet winner, but C won the election, so B's the Condorcet, but C won using the plurality method. So right there, that shows us that this election violates this criteria. Okay, so that someone at this point could be like, whoa, that's not a fair election because it violates this criteria. Okay, so that's what that means. All right. So those are the first 2 rules. Okay, let's move on to insincere voting. Okay, another flaw of the plurality method is that an election results can easily be manipulated by insincere voting, or voting for a candidate you don't really want to try to affect the outcome of the election. That's like voting for Kanye or yourself or something instead of Trump or Hillary in the 2016 election. Okay, so sometimes we call this a spoiler candidate. Okay, so a spoiler candidate is someone who stops the party from winning. Okay, for example, okay, see 2000 election. Okay, so what is insincere voting? There's no way that our true preference is going to win, so we vote for a lesser choice, so we don't waste our vote. Okay, so if I do the plurality method here on this one, R has 49 votes. Okay, H has 48. F has 3, and S and O both have 0. So here R wins. Okay, the way that people really wanted to vote, R wins the election. However, they were like, some people thought, oh, R doesn't really have a chance, so I'm just going to vote for H, because H seems like people really want to vote for them. So R still has 49, but H now has 51, and F has 0. So here, H wins, based on how people actually voted. So the key here, 3 people manipulated the election, okay, and changed the winner. Just 3 people did that. That's crazy. Okay. So, in its consequences, instance year voting is common in real elections. In 2000, 2004, or I just mentioned 2000, close races, Ralph Nader lost many votes. Voters now want to waste their vote. So, some people call Ralph Nader a spoiler candidate. Okay, I'll write that down here again. He's a spoiler candidate. Okay, because of him, we could have had a winner in the 2000 election. It was a clear-cut winner instead of having Bush v. Gore, right, in the Supreme Court, and having the runoff. So he is considered a spoiler candidate there. Independent and small party candidates never get a fair voice or fair level funding. Okay, an entrenched two-party system. Okay, two-party Democrats and Republicans. Okay. However, a fun factoid, did you know that the last time a third-party presidential candidate won a state and earned any votes in the Electoral College was George Wallace in 1968? I bet you didn't. Okay. So here, this basically is saying, okay, yes, we talked about how the way you count the votes matter, but your vote counts at the end of the day, no matter what, no matter which way you count it. Okay, because some people could be considered spoiler candidates, depending on how you vote. Okay. So example 4, use the plurality method to find the winner of this election. So A has 15 total first place votes. Okay, now my dog wants to play. Oh, she heard spoiler candidate and got really excited. Calm down, girl, calm down. Okay, B is 3, and C has 15. Okay, so it's this tie between A and C. Okay, first tie-breaking rule. If there is more than one alternate with a plurality of first place votes, then the tie is broken by choosing the alternate with the fewest last place votes, which is what we've been practicing in class. So you look at the bottom row here. Okay, A, last place votes here. A has 3 last place votes, and C has 10 last place votes. So here, the winner declared would be A. Okay, the other way to do it, okay, is broken by a head-to-head comparison. So you do A versus C. The 10 votes go to A. The 15 go to C. The 5 go to A, so they're tied. And then the 3 go to C. So you had 15 to 18, with the winner being C. So again, the way you determine a tiebreaker also can determine a winner. Always assume that ties are allowed unless a tie-breaking procedure is specified. Mathematically, unbreakable ties must be broken using a game of chance, like a coin toss, or rolling a die for the high number. If there is a tie, I'll specify how to adjourn and fix that tie. Okay? So what's wrong with the board account method? And don't say because it's too long. Okay, it's Mr. Ball's favorite, so you be nice. Okay, so let's use this table in determining a winner using the board account method. There's 4 candidates, so I'll start with A. We know we start with 4, 3, 2, 1. So A will be 4 times 6. I'm going a little faster because we've been practicing this a lot. 3 times nothing. Okay, and then we have A's at the bottom of the other 2, so that'd be 1 times 5. 24 plus 5 is 29. Okay, let's look at B. So B now would be 4 times 2 plus 3 times 6 plus 2 times 3. Okay, which gives us, let's see, 8, 18, and 6 gives us 32. Okay, let's look at C. C, we have 4 times 3 plus 3 times 2 plus 2 times 6. See, 12 plus 12 is 24 plus 6 is 30. Okay, and then we can look at D now. Oh yeah, I like that purple. Okay, D has no first place votes. It has 3 second place votes. So 3 times 2 plus, and then it has 2 third place votes and 6 last place votes. Gives you 19. Okay, so the winner here, well, I can double check my math here. 4, 5, 6, 7, 8, 9, 10 total points in the ballot, with 6, 7, 8, 9, 10, 11 voters for a total of 110 points. Okay, and if I grab my little handy dandy calculator here, 29 plus 32 plus 30 plus 19 gives me 110. Yay, we did it right. Okay, so the winner then would be B. B wins the election here. So how many people voted in this election? 11 people. I added that up above. How many votes you need for a majority? You take 11 divided by 2, 5.5. So you need 6 votes for a majority. And did anybody receive the majority of the first place votes? Yeah, A did. It was 6, exactly. Okay. But, look at that. Discrepancy there, right? Not the same winner. Okay, so let's see. Is there a Condorcet candidate? So let's check that puppy out. So, we have 4 candidates there. So let's do A versus B. So A gets the 6. B gets the 2. And B gets the 3, right? So we have 6 to 5. Okay. And then A wins that. Okay, A versus C. So we have A gets 6, C would get the 2 and the 3. So 6 to 5 again, A wins again. And then A versus D, we have 6, and then D gets the other 5. So A wins. So A is the Condorcet. And should have won the election. Okay, so that means that, okay, in this case, we have the majority criteria, the majority, and the Condorcet criteria is violated. Why? Because if you look at it here, A has the majority of the first place votes. A has the majority, but A loses the election in the vote account there. And A is the Condorcet, but A lost the election with board account. So this table here, if you do the board account, it violates 2 criteria. It's rare, but it happens. Okay, so plurality with elimination cannot violate the majority criteria. But what's wrong with it? It can violate the Condorcet. So rule 3, the monotonicity criterion. If candidate X is the winner of an election, and in a re-election, the only changes in the ballots are changes that favor X. So X wins in a re-election changes favor X and only X. Then X should remain the winner of the election. If they don't, boom, unfair election results, according to this criteria. All right. Whew, it's taking the wind out of me, kids. Okay, so, oops, I don't want to do that. 3 cities, Athens, Barcelona, and Calgary, are competing to host the Summer Olympic Games. The final decision is made by a secret vote of the 29 members of the Executive Council of the International Olympic Committee. And the winners will be chosen using plurality with elimination. We have 29 members. 2 days before the actual election, a straw poll is conducted just to see how things stand. Okay, so here are how things stand days before the election. Okay, so with the total amount of people who voted, the total was 29. So if you divide that by 2, that gives you 14.5. So the majority then would be 15. Okay, so I do plurality elimination. I have A, B, and C. A will have 11 first place votes, B will have 8, and C would have 10. Okay, so I'm going to eliminate B first. So B's gone. So those 8 votes go to C. So A has 11, C has 18. So C wins this election. Now, again, this is a straw poll. So 2 days beforehand, they release these results, all right, for the 29 people who vote. And they say, okay, C looks like they're going to win. Okay. Although the results were supposed to be secret, word gets out that Calgary's going to win. Of course. Okay, the 4 delegates represented by the last column. Okay, so these 4 people right here. These 4 people decide they're going to jump ship. They're jumping ship, people, and they're going over here to CAB. Okay, so they switch the votes, right? So now there's 14 here. There was 10 for CAB, and now there's 14. Okay, so now you're doing this as through Pareto elimination again. But still, the majority here does not change. Oops. Right? The majority is still 15. So A has 7, B has 8, and C has 14. Look at B. C only needs 1 more to win the majority. Okay, we eliminate A because they have the least. And look at that. Those 7 go to B. So B now has 15, and C has 14. So B wins. Okay, those 4 people, what they did actually, which was very ironic, those 4 people who voted for A said, oh no, A's going to lose. This is vote for C, which is their second choice. They did that, and some insincere voting there, okay, and actually gave C more votes that favored them, and only them, but ended up costing C the election with this method. So, quick perk. Oh, should say quirk, not quick. Okay. So a quirk with plurality, with elimination, is that you can actually do worse by doing better. Can you say, what do you mean by that? What do you mean by that, Mr. Baum? Well, C did better, right? They got more votes. C did better, right? But it actually cost them the election here. Okay, so this would be in violation. So this is violation. So that's my dog. Violation of the monotonicity, tonicity, T-O-N, tonicity criteria. Okay. So what's the problem with pairwise? Okay, pairwise elections cannot violate majority and cannot violate Condorcet. Right? The method of pairwise basically is Condorcet. And the majority, as we showed before, with, which one was it? Not that one. With this one here, okay, A was the majority, and as you can tell, always won. That one works. But what's the problem? Well, let's see. The NFL table shows the voter preference for a new NFL expansion team who should make the number 1 draft pick. If we check pairwise, so let's do pairwise, okay? And so instead of you actually having to do five candidates, and all that, which would be what? 10 head-to-heads? Okay, I have the winners right here for us. Okay, so if we look here, okay, A has how many wins? Well, A wins 1, 2, 3 times. B wins 1, 2.5 times. Okay. C will win 1, 2 times. E wins once, and D wins 1.5 times. So the winner is B. No, sorry, A. A wins. Silly Mr. Ball. Do better, Ricky. A wins. However, sometime after this vote was taken, we find that candidacy will not be in the draft. So candidacy drops out. So candidacy dropped out. Since he was not our top choice, it should not affect the results, right? Well, let's do it again. A. Anything that involves C needs to go, because C no longer is a candidate. Okay? So A now gets 1, 2 wins. B gets 1, 2.5 still. C's 0 because they're out. D gets 1.5. And E gets 0. So B wins this time. So A wins with all the candidates, but then C decides, you know what, I don't want to go in the draft this year, I'm not eligible, whatever. Drop out, B wins. Okay. And then rule number 4, the independence of irrelevant alternatives criterion. Okay. If candidate X is the winner of an election and one of the non-winning candidates withdraws or is disqualified, then after recount, candidate X should still be the winner. So that's what we just saw right here. So this example violated the independence of irrelevant alternatives criterion. Okay. So essentially, anyone who earned points for beating C loses them. Okay, which hurts them in the long run because he dropped out. So there's your 4 rules and examples of each. Okay. So the way you count votes matter, and the way you vote matters as well. And the way you vote matters. Okay? Because there could be spoiler candidates. So using this table, I'm not sure if you remember, the plurality winner was A. The border count winner was B. Plurality elimination winner was D. And the pairwise comparison winner was C. Okay, this was in previous lessons. So changing the method of counting votes, okay, might change the outcome of the election. Sometimes all 4 methods may produce the winner, and other times they won't, which I think you're starting to see in our practicing class, right? So is the election fair? Okay, and this term right here, fair, we'll be talking more and more about soon. Is there a candidate with the majority of first place votes? Yes. The candidate with the majority of first place votes should be the winner of the election. If they are not the winner of the election, then the majority criterion has been violated. Is there a Condorcet candidate? Yes. The Condorcet candidate should be the winner of the election. If they are not the winner of the election, then the Condorcet criteria has been violated. Was there at any point a recount or a re-election process? Yes. Then did the winner change? That is the winner of the original count different than the winner after the recount? Yes. In between the original election and the recount, what happened? A non-winning candidate dropped out or was disqualified, then the independence of irrelevant alternatives criterion has been violated, or changes were made to one ballot that only favored the winner, then the monoticity criterion has been violated. A lot to take in, but don't worry, okay? We'll get there. And lastly, probably one of the most important things in this unit is Arrow's impossibility theorem, okay, which states in the 1940s, mathematical economist Kenneth Arrow discovered a remarkable fact. For elections involving 3 or more candidates, there is no consistently fair democratic method for choosing a winner. In fact, Arrow demonstrated that a method for determining election results that is democratic and always fair is mathematical impossibility. This fact, the most famous in voting theory, is known as Arrow's impossibility theorem. All right, and that's the flaws.